All right, good morning, you guys. We're going to be talking about battery problems today. So we've been talking about basic electricity, and we've been talking about circuitry and so on. Now we're going to start looking at battery service, battery problems. We're also going to be looking at starting into starting system and charging system, and all this is going to take us a lot of time. We're going to look at things very carefully because I want to be sure to be thorough. I want you guys to feel like you're comfortable with all of these topics, and so we'll be doing a lot of stuff with them. So let's start off looking at battery problems. And so from my standpoint, these things that are listed here should be to some degree really an auto one review, but the truth is most let's say no crank, no start issues are all at the battery, at least 85, 90% of them, maybe even 95% of them. Yes, we can have an issue with a clutch safety switch or a neutral safety switch. That clutch safety switch won't let you start, won't let you crank if the clutch pedal is not depressed. Neutral safety switch won't let you start or crank unless you're in park or neutral. So that could be interpreted as a battery problem, and obviously it's not. An anti-theft system problem, either with a key or you've tripped the alarm or something, could be interpreted as a battery problem if it's a crank and obviously no start. Um, a transmission gear selection issue could again not allow you to be in park or neutral or something like that, and that could be interpreted as a starting problem. And obviously a starting system. So there's a lot of other things. There could be a computer issue, wiring problem that could be interpreted as um, uh, a battery problem. But in any case, 95% of the problems with a no crank situation are going to be directly with the batteries. Let's talk about it. So first, low electrolyte level is really muy importante, is very important. We've got to have that water up covering those plates sufficiently, or the acid can't react with the lead peroxide plates and the sponge lead plates. So two dissimilar metals in the presence of an acid solution produces voltage. We've got to have it full of electrolyte. Remember, a fully charged automotive battery has an electrolyte with 64% water and 36% sulfuric acid. As the water level goes down, you're just not going to have the contact between the acid in solution and those plates, and so your ability to make current to start an engine goes down. Secondly, corroded connections. So corroded connections is probably by far the number one no crank issue or slow crank issue or something like that. So we're talking about the corrosion on the top post terminals here, or we're talking about corrosion on side terminals. If this one was a side terminal battery, obviously it doesn't have the terminals here. And corrosion on the cables, and we'll look at that when we do a little battery service. We'll look at it closely. Um, Third, insecure battery hold down. This is not so common, but when somebody goes four-wheel driving and the battery gets loose from its hold down and is either pulling on the cables or something's happening physically to the battery because it's rubbing against something, and that's physical damage. Okay, the hold down's insecure. It gets thrown into the fan. I've seen that, and it starts leaking acid, and obviously it doesn't want to start. Those are not very common, but it does happen once in a while. And then less than 12 volts resting, 12.6 volts. And I want to remind you that I differentiate between resting and open circuit voltage. Resting voltage is really the battery is sitting there, nothing's on, or like nothing you have turned on, but the clock is pulling power for its memory. The computer modules are pulling a little bit of power for their memory. Seat position memories and stereo position, all that stuff is pulling a little bit of power. True open circuit voltage is you disconnect the battery cables. Nothing is pulling power from that battery. So even though we kind of say resting voltage means open circuit, true open circuit was you've disconnected the cables so the battery for the, so that the computer's not pulling any power from memory, this clock is not pulling any power, the stereo is not pulling any power, etc., etc. You've got to make sure that all of these things are as they should be, or forget it, it's not going to start right. You're going to have problems. And these are the two main ones right here, or really this one. And let me say something else about this one down here. Why would you have less than 12.6? and you could have it full of water and the connections could be clean. You just left something on. Your mom went into the store, you're sitting in the car, and you've been playing the stereo too long, and now the voltage is too low and it's slow cranking or it doesn't crank. It can happen. So this may be good and this may be good and none of this may be an issue, but you may have low voltage just because you left something on, or you've got what's called a parasitic drain, okay, or a drain on the battery, meaning something's drawing power from the battery that's not supposed to be. Yes, the clock's supposed to, yes, computer memory, yes, stereo presets, yes, seat position, those kinds of things are supposed to draw memory power all the time, but something else is, and we're going to be talking about that, and we'll be doing a parasitic draw or a battery drain test and showing you exactly how to do that later. Okay, let's keep going. So when we talk about battery testing, the first thing we want to think about is what's called battery leakage. And I'm going to bring it all up and then we'll kind of talk about it so you have time to jot down some notes here. So battery leakage, what this is saying is current flowing from the positive post to the negative post across the top of the battery. And it says here current can discharge across the top of the battery. Remember, B plus is my abbreviation for a battery. So whenever you see B plus, you just know we're talking about a 12-volt lead acid automotive battery. Using a DMM, digital multimeter, we're going to probe the top of the battery with the positive lead. So we clip the negative lead over here to the negative post, and we're just going to take the positive lead and just touch across the top of the battery and see if we have battery leakage. In other words, if we show any voltage. And it says clean the battery if the voltage is above 5 volts. Well, this is a fine test if you're trying to diagnose why you had a problem. There's nothing wrong with it. But what are most of us going to do if we suspect a problem? Or if we just look at the battery and we see it's all dirty? Well, we're just going to clean it. We're going to wash it off with water, and maybe we'll use baking soda, and then maybe we'll take the battery cables off the posts and we'll clean them. And so doing this test is, I guess, good if you really want to identify why you are losing current and voltage. But most of us are just going to clean the battery and service it, so we would never actually do this test. By the way, and this is new, I've got to start reminding people or telling you guys this all the time. If you disconnect the battery cables, consult ProDemand or service information like AllData. Consult it. Do a search on disconnecting battery, because many cars, when you disconnect the battery, want you to have to re-register that battery with the PCM. And or when you disconnect the battery, like on a Volvo, you can hurt a module on the car if you don't do it right. And finally, when you're going to disconnect the battery, to not get a customer upset, we want to apply an external power source to keep all the memories of the computers and power seats and power windows and all this stuff alive. And so we can do it a couple of ways. For example, we can take a jumper pack and attach it to the cable and then unbolt these cables. So the car is being powered up by the jumper pack while you're servicing the battery or replacing the battery. Or we do have a little battery device that we can plug into the cigarette lighter to power it up. Or we have a little power device that we can plug into the diagnostic link connector to preserve power. And I'll be showing you that in demonstrations, etc. Let's keep going. So continuing to talk about battery power, or battery testing, sorry, we can do what's called a battery terminal voltage drop test. Just real simple. We want to look at if the battery cable connections at the posts are good, or we want to know, are we dropping or losing? We use the word drop, that's the technically correct name, or losing voltage, trying to push current through some corrosion, which is resistance, at the battery terminal and cable connection. So this is going to test the battery cable connection to see how good a connection it is. It shouldn't drop any voltage. There should be 0 voltage being consumed, pushing that current through the battery terminal / battery cable connection. Is it normal that there is at least some corrosion in there? Yeah, that's actually normal. Is it measurable? Not really, not usually. It should be like 0 volts or 0.005 volts. In other words, nothing measurable. Okay, let's continue here. So we're going to connect the negative voltmeter lead to the battery cable end, and I think we got a picture here. Let's pull that up. We're going to connect the positive lead to the battery terminal. So in the picture right here, so in other words, we're going to put the negative, before you, don't worry about writing this down yet. We're going to put the negative onto the cable end. So connect negative voltmeter lead to cable end. And we're going to put the red, connect positively, the red lead to the battery terminal, so you're touching the terminal in the center. So what you're doing, let's just think about it for a moment, and then I'll give you some time to mark this down. You're asking the question, are we losing voltage or consuming voltage, pushing current from this post through that connection into the cable end? In other words, are we consuming voltage, pushing the current through that connection or that resistance that might be there? If in fact that connection is not 100%. Yes, you're going to disable fuel and crank the engine when you do this. So let me explain. Disabling fuel by pulling the fuel pump fuse so the fuel pump's off. So you go to crank the car and it starts and dies, then you crank it again and it doesn't start. Why is that? Because we want to push the maximum amount of current through that connection that it ever sees, which is the starter motor, which will be 150 to 175, well, 110 to 175 amps, depending on how big the engine, etc. So we want to disable fuel and crank the engine. And while it's cranking, we're looking at what voltage appears on the meter to say how much voltage did we lose or drop to push the current through that resistance. So theoretically, this lead post and this lead cable, although they're not lead anymore, but that metal post, that metal cable connected with it should essentially have zero resistance if it's a good connection. But any corrosion in there will reduce the amount of current flow by presenting resistance. And so what we're measuring is the difference in voltage from the terminal to the cable. It should read 0 volts if it's a good connection. So it says clean the connections if the voltage is above 1/10 of a volt. So if you see 0.5 volts, you've got some significant corrosion there. One time I had a car that was a crank no start, or maybe it was crank slow, or slow crank no start. And I went ahead and did this. Sure enough, I was losing like 5 volts there, and I had a terrible connection. Pulled the cable connection off, took my battery brush, cleaned it, and life was good after that. And so we'll look at that in a demonstration here in just a little bit. Let's keep going. So further battery testing, we can take a hydrometer and we can check the specific gravity of the liquid. So remember, we're comparing to water. Water has a density of 1. We use this hydrometer here, and you can see it says 1300, but it's actually 1.3 is the specific gravity of fully charged lead acid battery with 36% sulfuric acid, 64% water. But compared to the density of water, which is 1, we're checking the specific gravity. Okay, checking the specific gravity. So we don't normally use the hydrometer on automotive batteries much, or at least professional technicians don't. The one time that they will use it is when we think we have a bad cell and we're trying to identify one cell as having an issue. Okay, fully charged is 1.28 to 1.30, and as the battery B plus, my abbreviation, battery discharges, water percentage increases. We talked about this in Auto 1. Sulfuric acid percentage decreases, specific gravity decreases. When you recharge, water percentage decreases, sulfuric acid percentage increases, and specific gravity increases. So just the opposite. So obviously they're showing you taking a specific gravity, a hydrometer measuring the specific gravity, and they're also putting a thermometer in there because there's a temperature correction for the hydrometer based on temperature. But you guys, this is, kind of a scientific way of really looking what's going inside the cell. We're fixing the car. We're not spending this much time. We're going to clean the battery. We're going to make sure it's full of water. We're going to clean the connections. We're going to charge the battery. We'll test it. If it fails, we get a new battery. Okay? And one of the things that we're going to look at is date codes and just make sure, if it's a 7-year battery and it's 1 year old or 2 years old or 3 years old, we're going to say, wait a second, this thing should be testing good if it's serviced well. But if it's 7 years old and its capacity is down after we've serviced it and cleaned the connections and everything, it's time for a new battery. Okay, let's keep going. So you don't need to write anything down here at all. This is all this is showing. Please don't bother taking any notes. This just shows that there's a temperature compensation on the specific gravity reading. That's all it's saying. And I won't test you on that, and don't worry about it because it's not used very much. So again, here's a fourth test, battery open circuit voltage test. Battery open circuit voltage test. And I just want to remind you, before we look at this, that a true open circuit voltage test means that the battery cables are actually off, okay? I don't think that this is going to describe it that way. I think it's just going to describe it with turning everything off, even though there's still computer memories, seat positions, stereo presets, and clock running, okay? So we're going to connect a voltmeter to the battery. We're going to turn on the headlamps to remove the surface charge. And by the way, when we say connect the voltmeter or connect the digital multimeter, we mean red to positive, black to negative. What happens if you reverse the leads? It just reads negative. It doesn't hurt anything, but the screen will read negative. So just red to positive, black to negative, it's reading positive. You're going to turn on the headlamps to remove any surface charge that might be on the battery because let's say you had just driven it into the shop or something, and the voltage of the battery is elevated just because it's excited because the alternator was charging it at 14.5 volts. Okay, so we're going to turn on the headlamps to remove the surface charge maybe for a minute and then shut them off. A fully charged battery, should be 12.6 volts. So now what we're going to do is we're going to look at the voltage and say, okay, based on what the voltage is, how good is the battery? Just looking at what we're calling open circuit voltage. But again, true open circuit voltage, we would need to disconnect the battery cables, just FYI. So this battery is showing 12.49 volts on the battery. And you can't really see where they're connecting it very well, but they are connecting red to positive, black to negative. And it says this battery is 75% charged. Well, they give you charts that tell you that a 12.49 voltage is 75% of its charge, but hold it, just wait a second. When you go, it's 75% charge, you're like, wow, really? 12.49 is only 75% of 12.6? I don't think so. But they have a chart where they equate that lack of voltage to a percentage. So it doesn't really make sense in your mind, but that's what we are told when we look at this. Here's why I don't pay attention to this much, except in 1 or 2 cases. I don't pay attention to this much because the battery voltage is a little susceptible to having a surface charge because the alternator was just running, being down a little bit because you ran the radio for 3 minutes, or you had the headlights on for 2 minutes instead of 1 minute, meaning it'll fluctuate. Now, granted, when you shut the headlights off, you'll slowly see the battery voltage creep back up towards 12.6. But if you're expecting it to always be perfectly 12.6, forget it. It's just not a realistic thing. And again, especially because you have, computer memories drawing, you have clocks drawing, et cetera, et cetera. This is, in my mind, kind of an old school test, but I will tell you one place where it really is helpful. Okay, all I have is a voltmeter. I don't own a load tester or some more expensive, sophisticated testing equipment. But I have a voltmeter at home because a lot of people do. They're not necessarily very expensive. You can get one for, 30 to 50 bucks and maybe cheap, but a good meter is more like 100 to 150. A really professional meter is like 400 bucks. But I'm convinced the 135, 150 range ones with a good set of fluke leads is fabulous. This one happens to, I believe, to be a fluke meter here. We have a couple of these fluke 88s, and they're like, I think brand new, they're like $425. They're super expensive. But here's where it does help. Okay, car doesn't want to start, car doesn't crank. I just take my battery and I go out and I touch the posts of the battery with the voltmeter. And it reads 9 volts. Well, guess what? The battery's weak. Why is it weak? I don't know. Number one, service it, clean the connections, fill it with water. Number two, charge it. Okay, and then if battery voltage is good, it's starting the car. Well, I'm going to assume that either depending, let's say it was low on water. Okay, there's a good reason why it might have been low on voltage. Um, maybe it's being charged correctly, maybe it's not. Maybe somebody was playing, a light was left on, maybe not. Maybe there's a short. But bottom line is, if I clean the connections, I fill it with water, I charge it up, and it's reading about 12.6, we're in good shape. So that battery is kind of what we call a go, no go. In other words, if I put it on there and it's 12.5 volts, battery's fine. If I put it on there, it's 10 volts, battery's weak, or it's not weak, or it just needs to be charged, perhaps. If I touch the cables, put my hands over here, if I touch the battery cables, all right, but I don't touch the posts, and I see 10 volts, and then I'm thinking, and I go, well, then let me touch the center of the post, and it's 12.6. Well, I got a bunch of corrosion, but probably, obviously, between the cables and the terminals. So I can use the voltmeter on an open circuit voltage to kind of do a quick check, So my son-in-law called me with his 2006 Toyota Tundra and says, hey, it doesn't start. And I said, is it cranking? He says, no, it's not cranking. Do you have a voltmeter? Yeah, put the voltmeter on the battery. What's it read? He said 12.5 volts or 12.6 volts. Okay, battery seems to be fully charged. Then I had him said, okay, try and crank it and either do the headlight test to see if the headlights dim, or put the voltmeter on and see if the volt drops. And he did both. He said the headlights weren't dimming and the voltage didn't change at all. And so I know, based on that sort of simple open circuit voltage test, is that it's not a battery issue. He's got something else going on, an alarms, tripped, neutral safety switch, clutch safety switch, something else is going on. He doesn't have a battery issue. Okay, let's keep going. Okay, so next is a battery load test, and by the way, I will be showing you these tests, etc. So a battery load test is a way for us to stress the battery and do an accurate test. So hydrometer, not so great. Open circuit voltage, not so great, but it's a quickie. If I only have a voltmeter, it kind of gives me an idea what's going on. Battery leakage, we already talked about. We're not really going to do that. We can, but usually we just clean the battery. So now we're looking at a load test. Now this is a professional way to see how much current the battery can deliver for a specific period of time and maintaining a certain voltage. So it measures the current output of the battery under load. So let's talk about open circuit voltage is like measuring your pulse. It's an okay measurement, but it doesn't tell us a lot. But if we put you on the treadmill and we measure pulse and respiration and we look at your heart and all other kinds of things, then we go, okay, now we're stressing your body and we're really seeing how it does. So what we're going to do here is we're going to stress the battery and we're going to see how it does. We're going to measure current output under load, load being we're stressing it. The battery needs to be fully charged to do the test. And before I talk about these third and fourth, let's show the picture of the guy here. And we're going to do this in the shop so you see it. So the purpose of a battery load test is to stress the battery and see how it performs a certain amount of current, certain amount of time, not dropping below a certain amount of voltage. We got to start with a fully charged battery, because if it's not fully charged, I guarantee you it's going to fail the test. We're going to test the battery. We could say test load is 1/2 of the cold cranking amperage output for that battery. So if the battery is a 600 cold cranking amperage battery, we're going to try and draw 300 amps out for 15 seconds, and we're going to make sure the voltage stays above 9.6. Okay, so we're going to try and draw half of its rated cold cranking amp. If the battery says 580, then we got to pull out, what is that, 290 amps for 15 seconds and stay above 9.6. This is also called a battery capacity test and a carbon pile test. This is a Snap-on VAT tester. I think this is a VAT 60. The company that used to make this was a company called Sun, and Snap-on bought Sun. We have a Sun VAT 40. VAT is voltage amperage tester. These are load testers. So this over here is what's called a carbon pile. There's carbon plates that dissipate the current that you're drawing out of the battery as heat, and these vents let the heat out of the machine. But this is how we load the battery up to half its cold cranking amperage output. So let me talk about this for just a moment. Let me do this. I'm going to show you some things on the screen, but first let's talk about how we hook it up. So the way we hook the tester up is we're going to take the large cables, and we're going to load the battery by drawing current through the tester. So we're going to put on the machine, they call these the internal 18-volt leads. So the big heavy red cable, big heavy black cable, red to positive, black to negative. Hook it up backwards, it's going to read negative. And then the inductive amps connector, you clip over the negative terminal. Truthfully, you can actually clip it over either one, but they say the most accurate is around the negative. But if there are two leads coming off of this, you have to get around both of them, otherwise you won't get an accurate result. Okay, so red to positive, black to negative, and the inductive lead around the negative cable or cables. Okay. So what I want to do is I want to pull the camera over to the screen, or sorry, to the whiteboard. And I'm going to go ahead and just clean this off a little bit. And what I want to do is talk about results. So let's say I have Honda Civic, and it's got a very small battery, and its battery is like 450 cold cranking amps. So my test load, I should write this a little straighter so you can see it. My test load is going to be 425, sorry, that was wrong. Mr. L, losing it. 225 amps is what I'm going to try and suck out of that battery. And for 15 seconds, and I want to stay above 9.6 volts. So let's say I do the test. I start cranking up the load, and I get to, I'm watching the voltmeter. So here's the ammeter. I'll put amps here. Here's volts here. And I notice that I get to 9.6 volts. It was dropping all the way down to 9.6 volts. And I'm only at 200 amps. And I can hold it at 9.6, but it doesn't go any higher than 200 amps. So it was supposed to give me 225. Is that a bad battery? Well, no. It's maybe lost 20% roughly. I don't know exactly, but suppose it's lost 20% of its ability to produce current. But producing 200 amps for 15 seconds at 9.6 volts, and the cranking speed is fine, it still starts the car fine, you're not going to get rid of that battery. You may want to, of course, you're going to service it. And of course, number two, you're going to look at the date code and go, okay, it's a 7-year battery. It's year 6. It should be down a little bit, but it's still starting the car fine. If I'm going to move to Minnesota in the wintertime and I got to drive across the country, yeah, it's probably time to replace the battery just to make sure I've got all the cold cranking amperage that I could ever need when it's 0 degrees out. But if I'm down to 9.6 volts and it's at 100 amps and it cranks, but it cranks a little bit slow, and you've already serviced it and charged it, you want to replace that battery. We would say this is obviously only giving us 50% of our rated output. If it was cranking fine and still starting at 100 amps and holding at 9.6 volts, I'd say, well, as long as you're staying in town and as long as you're not going to, again, go on long trips where you might be stuck on the side of the road or where it's cold, that's not something you want to do, okay? All right, let's continue. So next we want to think about a battery drain test, or what's known as a parasitic drain test. This is going to be a test, and it's going to show us how to do it here, but this is going to be a test that we use to determine if something is drawing power out of the battery that's not supposed to be. All right, so we know clocks are supposed to draw power, computer memories, stereo presets, seat positions, those kinds of things are supposed to draw power. But something else that's not supposed to draw power we call a parasitic drain, or a drain on the battery. Okay, a parasite is something that lives off something else that's not supposed to. So it's going to talk about how to do that. So we're going to take the negative battery cable and we're going to connect an ammeter we're going to remove the negative battery cable, and we're going to connect an ammeter or test light between this cable and post. So take the negative cable off right here, and then we can either put a test light from here to here and see if it lights up, or more accurately, we can use an ammeter. Now, a couple of things. First, we want to disable all lights and the clock circuit if we can, so we can pull the clock fuse out. And then we're going to compare to ammeter reading specs. So let me talk to you about this a little bit. And then we'll get to this last point in a moment, so don't worry about that so much there. But what we're going to do is we're trying to determine if some power is going out of the battery when everything's supposed to be off. Now, on a modern car, yeah, we turn everything off. I don't normally take the clock out of the circuit because I know that up to about 50 milliamps or 0.050 amps is acceptable and pretty normal. You'll see cars be more like 0.025 amps for computer memories and clocks and these kinds of things. Now, on modern cars, most computers go to sleep after several minutes. Some stay awake as long as 15 minutes. So you'll see them drawing power sometimes 0.2 of an amp, 0.200 amps or 200 milliamps. And all of a sudden, after 15 minutes, it'll drop all the way down to like, 0.01 amp. Well, that's because the module finished charging up and we say it went to sleep. And I'm going to be showing you this on the car in the demonstration. The reason why first that I use a test light sometimes is just for safety. Meaning, if I put the meter in right away, this meter has a fuse, and it says right here 10 amp max fused. I don't know if you can't read it, but there's a 10 amp fuse here. If you put the ammeter in series like this is now, that's how we measure current going out of the battery. But if there's more than 10 amps, we're going to blow that fuse, and I don't want to have to take the back off and replace the fuse every 5 seconds. So a lot of times what I do is I'll take a test light, get the meter out of here, put the test light from here to here. If the test light's really bright, then I'm going, okay, it's probably drawing a lot of current. If the test light bulb is kind of orangey and kind of dim, I go, okay, it's low amperage. I'm safe to put this in. I can risk it with our new meters that have a 20 amp fuse in here. Or the other thing is, what we've done is we have we can put a wire in here that has a fuse in it. And I've got a wire that has a 20 amp fuse, and I put it between there. And if it pops the fuse, then just a regular replaceable automotive fuse like this. So for example, if I put a 20 amp fuse like one of these in there, then I just ruin a 10 amp fuse, and it's really easy to just replace that. And I don't necessarily have to take apart the meter. So if it doesn't pop the 10 amp fuse in this case, or in our meters a 20 amp fuse, then I'm safe to put this meter in there without worrying about blowing the fuse. Hope that makes sense. So there shouldn't be any reason you have anything close to a 10 or 20 amp draw, but once in a while it does happen and you blow the fuse in the meter. So, you could say, Mr. L, the test light thing is kind of maybe a waste of time. Okay, fine, I agree. Get a little fuse holder and let me show you one. So here's an automotive fuse holder, and it's just got 2 wires on it. You can see the wire there and the wire there, and it's aluminum wire. And it's got a fuse in here. So if I put this between this terminal and this cable like that, and the fuse pops, then I know, if this is a 20 amp fuse, let's say, then I know that there's more than a 20 amp drain, and I wouldn't want to hook my meter in there. And in that case, you say, well, what do? It's something high, something more than 20 amps. Okay, that's where this comes into consideration. That is, let me just get this a little bit lower there. If the reading is high, we're going to isolate the problem by pulling one fuse at a time. So let me explain. So I go through and I pop fuses. Well, wait a second. You say, if you pull out a fuse and you reconnect this and you blow another fuse, well, that's no good because I keep blowing these fuses. So, okay. So I have a little jumper wire with a light bulb. And if I put that there and it won't pop the fuse because it's lighting up, and I pull this fuse and nothing changes, and I pull this fuse and put it back in, nothing changes. All of a sudden I pull this fuse and the light goes out. And I go, hey, I think I found the circuit that has most of the problem in it. And now I go, okay, I'll put the fuse holder back in with that one out, hook it up and go, oh, it didn't blow. So now what I'm going to do is with that fuse out, I'm going to put the meter in and see what actually measure the draw. And if it's way down at 10 milliamps, 0.010 amps, then I'm going to go, okay, the circuit that this fuse was protecting, that's where the problem is. Because when I take it out, I only got a 0.010 amp or 10 milliamp draw, which is totally acceptable for computer memories, etc. But when I put it in, it lights up that light bulb and it already popped a fuse, so we know it's something more than 20 amps. So in this circuit, and let's say this is a power window motor circuit that fuse protects. Well, now I go to the wiring diagram and I kind of look at the circuit with that fuse, and I start going, okay, here's the problem. Here's something going on that we're drawing a lot of power on. And obviously if it was more than 20 amps, then this fuse, let's say this was the 30 amp fuse and it's not blowing, but when I put the 20 amp fuse in, it did blow. Or in another case, in a case where this was blown, we already know we got a big old short in that circuit and we can deal with it, or we can search for it by looking at the wiring diagram. But anyways, we look at the wiring diagram and we say, okay, where are the places where we could get draws? Okay, let's talk about power windows. The most common place for a power window short is maybe in the wires in the door hinge. I've seen that before where the wires in the door hinge either pull apart or they get stretched and they touch ground and they short, or something in the motor is shorted. Think something mechanical. Where are the mechanical moving parts in a power window circuit? Well, in the door jamb where the wiring harness passes through, or with the motor, or could be with the switch or some wiring, but most likely it's going to be the motor, or maybe the mechanism of the power window thing is coming down and touching a wire and shorting out. Okay, so I know that you may have questions, and this is a little bit difficult to understand. When I do the demonstration in the shop, which will be coming after this, it will probably make a lot more sense. So let's keep going here on to the next thing. So I think this may be the last test that we have, or maybe there's one more after this. A 3-minute charge test is a test that's performed in 3 minutes to try and determine if a battery needs to be replaced or not. And basically what we do is, let's say we have a battery that's drained down, and we look at the date code and it's 4 or 5 year old battery, and it's 4 or 5 years old, and it's a 7-year battery, and you're thinking, is this thing bad, or is it just got drained down and it just needs to be charged, etc. So in 3 minutes we want to try and decide if the internal condition of the battery is such that just recharging it for, let's say, 6 hours is going to solve it, or if we need to get a battery. So it's a way of diagnosing a potentially bad battery in a very short period of time. So we do this test if we get a battery that's a very low state of charge and is not looking good. We're going to charge the battery at about a 30 to 40 amp rate for about 3 minutes. Okay. At the end of 3 minutes, that's a better way to say it, we're going to test the voltage at the end of 3 minutes while the charger's still on. If we've got the battery, this is a battery charger charging this battery, and we've got a voltmeter in parallel here. If after 3 minutes with the charger still on, the voltage on the voltmeter is above 15.5 volts, then we're going to say we need to replace the battery. If it's below 15.5 volts, we're going to say we don't need to replace the battery. What this is telling you is if the voltage is above 15.5 volts, that is saying that the internal resistance of the plates, because they're sulfated, they're coated with the acid sulfation on the porous lead plates, they're coated to the point where it's requiring a lot of voltage from the battery charger to push current back into the battery. Now, granted, this isn't the most accurate test in the world, but if somebody brings you a battery and it's at a low state of charge and you want to recommend charging it really low rate, like a half amp or an amp, for 6 or 8 hours and then retest it. And they're like, I don't want to wait to know 6 or 8 hours. Do a 3-minute charge test, look at the date code, and give them your best assumption. If you say, well, it did a 3-minute charge test and it was up at 16 volts, and it's a 6-year-old battery, and it's a 7-year warranty, 84-month, it needs a new battery. Okay, you can reasonably say that. Okay, I hope that makes sense to you. Okay, so this is just a reminder on jumper cable connections, although I am going to show you a video on doing this. Just want to remind you, I always recommend, in this case, we are starting with, we start with the dead car. So here's the dead car, here's the live car, so dead battery, live battery. Step 1, put the positive post on the positive terminal of the dead car. Step 2, put the positive post on the positive terminal of the live car. Step 3, put the negative cable on the negative post of the live car. Step 4, and this is the critical step. The last step is where you're going to get a spark. You want to put this, now this says chassis ground away from battery. That's wrong. It's on the engine, not the chassis. On a non-painted metal engine surface. Why engine? Because the negative cable bolts onto the engine. So putting this on a non-painted metal engine surface is essentially the same as attaching it to the negative battery terminal. Why don't we want to attach to the negative battery terminal? Because if we get a spark at the battery, and batteries from time to time, depending on if you've been trying to start the car or charge it or something, is giving off hydrogen gas, you could blow that battery up and spray battery acid everywhere, and that would be a disaster, okay? So just a reminder, red to positive on dead car, red to positive on live car, black to negative on live car, black to non-painted metal engine ground on dead car. So I look at it as 1, 2, 3, 4 is like going in a circle like that, starting at the dead car at the positive side and ending up at a non-painted metal engine ground surface. I hope that makes sense to you. This one just shows us putting the cables on the dead car, red to positive and black over here to a non-painted metal engine surface, not chassis, engine. Okay, all right, there we go.